The arrival of Comet 3I/Atlas into the inner solar system sparked a wave of excitement, curiosity, and speculation among astronomers and space enthusiasts alike, particularly because it originated from beyond the boundaries of our own planetary neighborhood. As only the third known interstellar object ever detected passing through the solar system, 3I/Atlas naturally attracted intense scrutiny. Some observers, fueled by memories of earlier enigmatic visitors, such as 1I/Oumuamua in 2017 and 2I/Borisov in 2019, wondered whether this newcomer might be something more than a natural object, perhaps even an artificial probe sent by an advanced extraterrestrial civilization. While such ideas captured public imagination, the scientific community approached the object with careful skepticism, guided by empirical evidence and methodical observation rather than speculation alone. To address these extraordinary claims, astronomers turned to one of the most sensitive radio telescopes on Earth, the Green Bank Telescope, as part of the Breakthrough Listen project, an ambitious scientific initiative dedicated to searching for signs of intelligent life beyond Earth. The Breakthrough Listen program is designed to detect what scientists call technosignatures, measurable signals or patterns that could indicate the presence of advanced technology. These might include narrowband radio transmissions, unusual energy emissions, or other anomalies that cannot be easily explained by known natural processes. When Comet 3I/Atlas was identified as an interstellar object, researchers recognized a rare opportunity. If an alien civilization were to send probes to explore neighboring star systems, such objects might resemble or disguise themselves as comets or asteroids, using natural appearances as a form of camouflage. Though this idea remains firmly within the realm of theoretical discussion, scientists acknowledged that failing to investigate such possibilities would leave important questions unanswered. As a result, targeted observations were carried out, carefully scanning 3I/Atlas for any radio emissions or behaviors inconsistent with a naturally formed comet. Despite the excitement surrounding the search, the results aligned with what most astronomers anticipated. The observations revealed no signs of artificial radio signals, no structured emissions, and no evidence of technological activity. According to Benjamin Jacobson Bell of the University of California, Berkeley, the lead researcher involved in the study, the absence of technosignatures was both expected and reassuring. Existing data strongly supported the conclusion that 3I/Atlas is a conventional comet composed of ice, dust, and rock, exhibiting behavior entirely consistent with known physical processes. Its trajectory, outgassing patterns, and spectral characteristics matched what astronomers expect from a comet that formed around another star and was later ejected into interstellar space. While some may find the lack of exotic discoveries disappointing, this outcome reinforces confidence in the scientific method, demonstrating that extraordinary hypotheses require extraordinary evidence. Importantly, the decision to investigate 3I/Atlas was not driven by sensationalism, but by scientific responsibility. The researchers emphasized that even when the probability of finding something artificial is low, it is essential to test such hypotheses when the opportunity arises. The history of science is filled with moments when unexpected discoveries reshaped our understanding of the universe, and dismissing possibilities without investigation can lead to missed breakthroughs. In this case, checking for technosignatures ensured that conclusions about the object's nature were grounded in data rather than assumption. Jacobson Bell himself acknowledged that while the evidence weighed heavily against the comet being an alien probe, neglecting to verify that conclusion would have been a disservice to scientific rigor. The fascination with interstellar objects extends beyond questions of extraterrestrial intelligence. These visitors offer invaluable insights into planetary systems beyond our own. Because comets like 3I/Atlas formed around distant stars, their composition serves as a natural sample of material from other regions of the galaxy. Studying them allows astronomers to compare the building blocks of planetary systems across vast distances, shedding light on how common, or rare, certain chemical ingredients may be. In this sense, even a completely natural interstellar comet represents a scientific treasure, carrying information that would otherwise be inaccessible with current technology. Each such object deepens our understanding of how stars and planets form and evolve throughout the Milky Way. The idea that alien civilizations might send probes into interstellar space is not purely speculative fantasy. It is a concept rooted in serious scientific discussion. Jacobson Bell pointed out that humanity itself has contemplated similar strategies. The Breakthrough Starshot Initiative, for example, proposes launching thousands of ultra-lightweight probes toward Alpha Centauri, the nearest star system to our own. These probes, propelled by powerful laser beams, would travel at a fraction of the speed of light, potentially reaching their destination within decades. Though still theoretical, the concept demonstrates that interstellar exploration via small, fast-moving probes is technologically plausible, at least in principle. If humans can imagine and plan such missions, it is reasonable to consider that other technologically advanced species might do the same. From this perspective, the search for technosignatures on objects like 3I/Atlas becomes part of a broader effort to understand humanity's place in the cosmos. Scientists are not merely hunting for aliens, but exploring the boundaries of what is possible, both technologically and biologically. The question of whether intelligent life exists elsewhere in the universe remains one of the most profound and enduring mysteries in science. While the absence of evidence from 3I/Atlas does not bring us closer to answering that question definitively, it helps narrow the range of possibilities and refine future search strategies. Moreover, the public reaction to interstellar objects highlights the deep human desire to connect with something beyond Earth. Each new discovery reignites age-old questions about whether we are alone and whether other civilizations might be watching the stars with the same curiosity. Although science often delivers sober, incremental answers rather than dramatic revelations, this does not diminish its wonder. On the contrary, the careful study of objects like 3I/Atlas demonstrates the remarkable capability of modern astronomy to investigate even fleeting visitors from other star systems with extraordinary precision. In the end, Comet 3I/Atlas may not be an alien spacecraft, but its passage through the solar system remains significant. It serves as a reminder that the universe is dynamic, interconnected, and far from isolated. Material from distant stars can and does reach our cosmic neighborhood, offering glimpses into environments unimaginably far away. While the search for extraterrestrial intelligence continues, each investigation, successful or not, adds another piece to the puzzle. The lack of technosignatures from 3I/Atlas closes the door on one particular speculation, but it leaves open countless others, ensuring that curiosity, exploration, and scientific inquiry will continue to drive humanity's quest to understand the universe.